Okay, thank you gentlemen for your time and for having me here. So the obligatory Intel slide, what I'm here to talk about is the Lustre file system and the work that we're doing there. Intel's moving more and more into HPC and investing a huge amount both in the hardware side and, as you'll see here, in the software side. A little bit of an agenda. I'll try and get you some of your time back. I really came from the Lawrence Livermore National Laboratory. About 3 years ago, those of us in the Lustre community felt that there was a bit of trouble with respect to the technology. Oracle had ended up with the technology and wasn't really servicing our industry. And I was at the Lustre user group actually, and the guy beside me leaned over and said, somebody ought to do something about that. And I'm a sucker for challenges. So I quit my job at Livermore, started up a company by the name of Wham Cloud, and went out to preserve Lustre for the HPC community. Coming from the HPC community for 25 years now, I felt it was critical to keep an open source parallel file system available to my community, basically. I talked Eric Barton into joining me. He was the chief architect on Lustre for the past several years. Since Sun took over it in about 2007, Eric Barton was the main technical lead. And we really went out to make sure that this technology didn't disappear. Along the way, we ran into quite a bit of support from the community. I thank you for that. The company, Whamcloud, did quite well as we went along. In very short amount of time, we had gathered up pretty much the A-team with respect to the talent pool. And we were starting to do the releases again. So we stepped out and said, we're going to do a maintenance release every quarter, and we're going to do a feature release every 6 months. And so as you'll see in a subsequent slide here, there is a roadmap. Confidence is returning. Things were going well. We ran into a situation where we had a lot of interest out of industry. Yet when you talk to Wall Street and big pharma and oil and gas, they don't like interacting with a 50-person company. They want to see more substance there. And so while we were doing well in HPC, we saw the applicability of this technology to markets broader than HPC. Lustre is an expensive piece of software. It's GPL, it's open source, but it takes a lot of people to work on this software and keep it robust and keep it going. HPC, and to the large extent, the US government has shouldered a lot of that expense. And so I started getting the idea that if we could expand the user pool for this technology, we would feed a market for the storage hardware partners that we weren't part of, but we would grow the marketplace for everybody and therefore reduce the costs for HPC. At the point we succeeded in keeping it stable for HPC, we felt like there was more to come. Intel came around and started talking to me about then, and I realized if we were to take Lustre to the next level, we had to be this bigger company, and Intel would be an appropriate suitor. And so just after ISC last year, about a year ago, we sold the company to Intel. We had survived 2 years minus 1 business day from when we started. So it was really a rocket ship ride. We are all still intact at Intel. We've lost 1 individual over the past 11.5 months. The team is still intact. The team is very interesting because it's a model virtual team. We have 75 people in 10 countries and more time zones than I can possibly count. There's many people that work in this department, this division, HPDD at Intel now, that I've not physically met, but I hired remotely over the net and over the phone. It's a very interesting experience. There should be a book written on this, Rich. So 3 years ago, you could really get Lustre from one source, and that was Oracle. We set out to build what Intel calls fellow travelers. We set out to build others that cared about Lustre, wanted to sell into that marketplace, either compute, storage, or services, and rallied them around the idea that there would be a single tree. Along the way, 2 user groups started up, the Open Scalable File Systems in North America and the European Open File Systems here. And both of those groups rightfully pointed at the tree that we were that we were tending for and said that that is the root of the Lustre tree that we want to all work from. So while there was speculation that there may be forking in the tree going on, it never really happened. Everybody draws from the tree that we produce to do their own work with the code. This is the roadmap that I spoke about. It actually comes off left the screen by a year because it was in January of 2011 that we started putting releases out. We've hit all the releases. With software, of course, you can never be 100% accurate. So the 2.4 release was a month late or something, but within the error bars of a month or so on each of these releases have come out and they've been solid. The feature releases along the bottom here, the boxes below tell you what features have gone into those releases or are going into those releases. That has been highly accurate in the sense that when we say something's coming out in a 2.4 release or a 2.5 release, it does come out in that release. The legend here talks about which group is either doing the work and or paying for the work. Since we were a small company and now a for-profit division within Intel, we need to be paid to do these things to cover our bills. And so the 2.4 release came out in at the end of May last month. And I want to talk a little bit about I'll talk about the features, but this graph talks about the activity in the community. There's a bug on it because the bottom line should be 2.0, but this is, the 2.0 line was Oracle here. And then as we move up, it was Whamcloud and now Intel doing the lion's share of that development. The big bar in each of those is my group. What you see, though, is both accelerating development. The legend at the bottom is lines of code changed. That's added or deleted. You see that we had 35,000, 55,000, 90,000 lines of code change in the recent couple of years. But what you also see is an increasing number of contributing parties, to the point where the 2.3 release up there has that list of parties along the right-hand side that have code into the tree. One of the, I think, critical changes I made in the contribution model is we moved away from a copyright assignment contribution model. It used to be if you put code in the Lustre tree, you assigned copyright to Oracle. I didn't like that because what it does is it gives one entity entire ownership of the tree when I feel it belongs to the community. So that one entity could do something bad. In this case, we had an issue with Oracle and their ownership of it. So we've spread that out. Quite literally now, Lustre is owned by the contributors, by the community, by you guys and your companies. I'm very happy about that. The other thing you'll notice is that our percentage of contribution, my group's percentage of contribution, is shrinking. We started off at 95% and have gone down to 75%. The 2.4 release, which the data is still being gathered, my group actually participated in about 50% of the code changes. Other two major groups are Oak Ridge National Lab and Livermore National Lab, but what that's showing is that the community's rallying around the open source tree and everybody's starting to shoulder the work. It's not just the main contributing group from us. I'll skip 2.4 highlights. These are important features that are just in now. The main one being the metadata performance. Up until now, didn't matter what size of file system or supercomputer you had, your metadata performance would peak out at about 20,000 file creates per second. There's lots of metrics in here, but the simple one is if your machine starts up, your application wants to open files, it can do so at a rate of about 20,000. That started being a bottleneck. Imagine on the Sequoia machine at Livermore where you've got 4.5 million threads. If every MPI task wants to open a file, you're going to sit a long time and wait for that to happen. So we went through and did an SMP scaling work, which affects both the data stores, the OSSs, as well as the MDS. And what we were able to do is, taking advantage of multi-core and multi-threading, give you a 4 to 10x performance improvement in your existing hardware. So if you upgrade to 2.3 or 2.4, you can expect a 4 to 10x performance improvement in the metadata performance. That is vertical scaling. The next thing we did is horizontal scaling. We allow you to use multiple metadata servers at this point. It's done in a static way where you do there's a a root level command to do a make dir on a remote metadata server, but you can have as many of them as you want. And in fact, we tested this just in AWS on the 5 cents an hour kind of hardware, and we were able to produce about 150,000 file creates per second. So the roadblock there has been completely removed. Layout lock is an interesting feature that supports HSM, but also supports more enterprise class features such as data replication, load balancing across your data stores. HSM itself was a feature that we had promised in the roadmap for 2.4, and we've only gotten the client side in 2.4. We've not got the server side. And so we're going to have to wait till 2.5. That's the one exception of something major that did not make the releases. HSM is something that we really, really care about, and we're doubling our efforts. We send half a dozen of my engineers over to Europe every quarter to work with the CEA. The CEA is the group that's developing that code. We're not developing it. We're helping them get it into the tree. The OSD API fixes an issue that we've got with the underlying file system. Today, Lustre sits on top of an ext file system. One of the aspects of the ext file system is if you've got a file corruption or a data corruption, you do an online FSCK. With a 4 terabyte disk, that can be 8, 10, 12 hours. You cannot bring your file system up until that offline FSCK is done. So Lawrence Livermore sponsored us to rewrite the underlying file system interface, and we can now sit on top of the ZFS file system, or Btrfs in the future, or other file systems, even object stores. So the nature of the ZFS file system is that you don't have this offline check. You can do checking online, and you can bring your system back up quicker. That is an important feature that I think will be used a lot more in the future. So there's another couple features here. More 4 megabyte IO and network request scheduler were contributed by our friends at Zyrtec. So not just my team again doing the work. Earlier this week, I announced in San Francisco a new bundling of Lustre aimed effectively at the enterprise class users. This is called Intel Enterprise Edition for Lustre. And you can think of it the way you think of Red Hat. What we're doing is doing a lot more testing and a lot more packaging with business-like features, SLAs on support, management tool infrastructure, Intel Manager for Lustre, and the marketing materials that go with that for our partners to take this to the enterprise market. I'm hesitating on the word enterprise because I think much of the HPC community can take advantage of this sort of packaging of the technology. I realize that not every site wants to dedicate 2 or 4 individuals to running their file system, but that's what happens in the top 10 type systems. What we're doing is maturing the technology and wrapping it such that we can hand it to sites that do not want to dedicate a body to their file system. A standard Linux admin can make use of this technology wrapped like this. We have a roadmap for this. Remember, my group does the open source releases for the community development technology, and that's the top line in this. So what you'll see is a spin off that last roadmap where we've got 2.4, 2.5, 2.6, every 6 months a feature release coming out, and we'll be trailing that by just a little bit to bring that technology, the most recent features and combination of bits that's appropriate to the other part of the market, the enterprise part of the market, and bringing that to bear for the channel partners to take there. Another thing that we've added into this, we heard Addison talk a little bit about the big data market. Intel about 3 months ago introduced the Intel distribution for Hadoop. That's not generally thought of as an HPC technology, but what we found is that many HPC sites are being asked now to run Hadoop. We learned 10 years ago that we don't want to have disks in our nodes in an HPC architecture. So we've got compute over here and disk over here. Along comes Hadoop, and their architectural model has a node with local disk. So if you're an HPC center, you've already separated the two. If you have to run Hadoop, your options are one, to put the disk back in the nodes, which you don't want to do, or you can use the adapter that we've written, which is basically a Java class that replaces the Hadoop file system with Lustre. A couple of benefits of that is we can feed you your data at the network bandwidth rates. So if you're running at QDR or FDR, we can feed you your data at that rate, which is generally a lot faster than local disk can provide you that data. The second aspect is when you write out your results, it's already global. The Hadoop model does a whole lot of shuffling and cross communications to merge these results. What we've done is eliminated that because you're already writing out a global state. It turns out that you run faster, anywhere between 10 and 30% on the preliminary benchmarks that we've done, which are the Hadoop benchmarks. So it may be a little bit premature to claim success in the sense that I don't think we can take this to the Hadoop community and try and convince them to go to a global parallel file system just yet. But what I think it does is it lets those of us in the HPC community who have already done the architectural separation, it lets us use Hadoop in a more powerful way than the Hadoop community uses it. You can scale your compute separate than your data with this model. With the standard Hadoop model, you have to run on the nodes that have your data. So I think this has some upside, and we're getting it out into the community as fast as we can. It will come out in Intel's version 3 IDH, Intel distribution of Hadoop. It will come out in that, and it will also come out in our enterprise edition of Lustre. I'm in a group, here's another benchmark. I'm in a group of fellow software managers at Intel. There's 8 or 10 of them, and they do a lot of other technologies that I find to be synergistic with what we're doing with Lustre. There's power management, there's intelligent caching. You can expect us to be working with those other groups to try and see whether their technology makes sense to pull along in this way. Give me a time check for the fast forward work, Brian.
You good?
Good? Okay. So about a year ago, maybe 13 months, in June of last year, Whamcloud won a rather significant contract with the US Department of Energy. It's called the Fast Forward Project. And the US government got 7 labs together and took about $70 million, 7-0, and decided to place some early bets on exascale technologies that they felt were important to start moving down the road. They invested in processor memory and IO storage. In the processor and memory categories, Intel and NVIDIA and all the memory manufacturers that you're aware of won those pieces of money. In the IO portion, Whamcloud took the only contract that was offered there. It was an $8 million contract, and it's really to do big R research as to what comes after POSIX. POSIX is a limiting technology for IO as we move forward based on all the locking and some of the semantics in there. So we've got a group that comprises ourselves now at Intel, the HDF group, because we're going to go to an object storage model, and the first schema that we're going to work with is the HDF schema. We're working with EMC, who's doing burst buffer technology and IO dispatcher. EMC hired John Bent, who did the PLFS work at Los Alamos, and so that's a critical piece here that we're using. Cray is doing large-scale testing for us, and DDN is doing a versioning object store. The way to think about this is there's pressure from the programming model side to get rid of the bulk synchronous programming models. Today, most applications work in a way where they do compute, they hit a barrier, they do IO, they hit a barrier. They have these global barriers to make sense of things, and therefore there's a lot of white space, wasted space in your application runtime, either on the compute side or on the IO side as you wait for these barriers to come back. We're suggesting a more asynchronous IO model to go along with the asynchronous programming model. And the intent of this is to squeeze the air out of your application so you're not busy spinning CPUs to heat the room. And the way to think of this is you've got an object storage model that is transactional, just like a database. Your application's running along, and any one of your MPI tasks can raise an exception and cause a rollback to a previous generation of the data. The vertical lines running through the cartoon in the upper right, so each horizontal line is an MPI task. The vertical lines are called IO epochs, And those are the points in time when your data is consistent in the storage model. So your application can decide for itself, when am I self-consistent to the I/O subsystem? Send a flag to the I/O subsystem saying, whatever you've got for that data, that's consistent, go away and persist it. The application, of course, the simplest way to think of this perhaps is checkpoints. After every task has checked in and done its checkpoint, you've got a consistent checkpoint model. You can decide to persist that to disk and throw away the nth-1 one if you want. But we're dragging that forward to let you do this sort of thing with your own data model. Now the rules here are slightly different. Unlike POSIX, which has a model that when any task writes a location in the file, the next read from anywhere else in your application gets that updated data, we're not allowing you to read from within the current epoch. You can only read past epochs where the data is self-consistent, and you only write future epochs, okay? So this model should remove all of the locking aspects and bring us forward into a much more efficient model of I/O. The architecture that we're working for here, and this is driven by the Fast Forward project, you've got your favorite high-performance computer in the upper left. We envision, much like Cray does today, a I/O wall that's hanging off of your internal fabric. The performance numbers that we're aiming for here are 200 terabytes per second to that I/O subsection of your system. The little yellow boxes hanging off the side are some solid-state storage, such as SSD or NVRAM. That allows us to buffer up things like small IOs, which don't do well when you have a streaming file system underneath them. The intention and the goals are to then stream the data across that blue arrow on the top going down to the right at a mere 20 terabytes per second. Today, the fastest Lustre file system is on the K machine, which is a Spark architecture, by the way, to show about our independence here from Intel architecture. And that system runs at 2 terabytes per second. So we've got about a factor of 10 increase there. Rotating disks are not going to increase naturally a factor of 10 on their own, so there's going to be some other work having to happen there. So on the right is your storage cluster. It looks a lot like what you think of today as a Lustre file system. One thing that we're adding here, though, are those little red boxes for analysis shipping routines. What we want to do is allow the user to spin up a virtual machine directly on the storage to be able to do activities with his own data. So for example, if you've got a data set that's strung out maybe in a row major order and you need to cut through in a column major fashion, you could do that data filtering on the storage box itself and only ship the 1% of the data or the 10% of the data back to the scientist's workstation that's working on his Viz model, for example. As this matures, you could imagine that we could do visualization local with the data, right? This really looks like a Hadoop model again. It's taking the compute to where the data is. So we're building up the infrastructure to let you decide whether you bring the data to the compute or take the compute to the data. The last thing to point out about this is that we're using the HDF object schema, and the workflow for the HDF guys is to jump into a Python script and not use a standard shell script like a Bourne shell or whatever. So they've got their own infrastructure already built up. This will be, first order, this will be completely transparent to the scientists who are using the HDF interface today. They will get to take advantage of this because the HDF group is writing the appropriate middleware to take advantage of what we're doing here. The end result is that we will give you a Lustre file system. Today it's got only the blue box, which is the POSIX striped files, the stream of bytes way that we think about data today. We're adding the green box, which is the HDF simulation. This will sit in the same namespace, so you will CD around your directories, you'll find one of these files, and it will self-identify, and you'll have to jump into your Python script to make sense of the HDF file or whatever the middleware is for the other object stores. All of this is open source. All of this is being described on the web. All the architectures are published as they're approved by the DOE. So in the future, you'll have storage with more than just POSIX files in it. It's called DEOS for distributed application object store. So, and to sum this up, there's a lot of Lustre activity here at ISC. I invite you to come to the BOF, to come to our booth, the Intel booth. Eric Barton will be there Tuesday, Wednesday at 10 a.m. You can ask him the hard questions about how fast forward works in Deos if you like. You can try asking me, but he'd give you a much more accurate answer since he's working on it. In summary, I strongly believe that Lustre belongs to you, the community, and I want the community to realize that and be more active in steering where it goes in the future. And that's it for me.